Good afternoon everyone, and welcome to this case study webinar with RG Parkins Partners. Peter Coombs. If this is your first experience with the webinars, you'll see there's a little message pop-up that's appeared in your screens. Do feel free to post questions, and we'll endeavour to answer those at the end of the webinar through compiling the questions and then providing frequently asked question sheets. So we'll answer them and distribute after the event. So I'd like to introduce you to the participants in today's webinar. I'm delighted to introduce you to Peter Thomas. Peter works for RG Parkins Partners in Kendal, in the northwest of England. And I'm with my colleague here, Max Anderson. So Max and I are based in Newbury. Peter's remotely hooked in from Kendal in the Lake District. So after I've done a very brief introduction, I'll hand over to Peter, and there'll be a slight delay whilst I hand over the link, and then you'll see Peter's presentation. So thanks again, Peter, for participating, and for Max for all of his hard work involved with the scheme in the early days that we'll enjoy very, very shortly. So in terms of the order of the day, what I plan to do is hand over to Peter, RG Parkins and Partners, who will describe how SuDS were designed to serve a new housing development on a greenfield site in the northwest of England. The presentation shows how the MDSuDS module of MicroDrainage was used to assist this throughout the process, including planning, design, and for a successful approval at the end of the day. The project faced several challenges, including particularly steep site. There were issues with the Section 278 access, and also there was existing flooding, as well as local opposition. So it's a credit to the team. It's a credit to Peter, along with Story Homes, who we'd like to thank for presenting and sharing this experience with us. So the project faced several challenges, and it does provide, at the end of the day, though, a blueprint for various numerous developments for this of this type around the UK. So hopefully it will help you all. So without further ado, I'll hand over to Peter, and Peter will present the case study. So if you just bear with us for a second, I'll make Peter the presenter.
Okay, thank you again everyone who's attending the webinar today. As Peter said, my name's Peter Thomas. I'm from RG Parkins Partners Ltd in Kendal, up in Cumbria, and we've kindly been invited by XP Solutions to present to you a case study of the practical application of MDSuDS in a steep catchment. And in doing this, we'll be looking at a housing scheme which is also in Kendal. To give you a brief overview of what I'll be talking to you about today, we'll have the mandatory introduction of our company and the type of work we're involved in, much of which will no doubt be familiar to the majority of the audience. We'll then introduce our client before looking at the site itself and the serious challenges it presented from an engineering perspective. I'll then touch on the approving authorities involved with the scheme and the various requirements and relationships we have there. Again, something I'm sure you'll all relate to one way or another. This will lead us on to the requirements for SuDS, both generally and specific to the site. And from this, it will become clear why we needed to rethink our approach to SuDS modelling due to the constraints of the site. And I'll explain why we took the decision to use MDSuDS, followed by how we use the information generated from the software in a practical application, with an update on the scheme and a recap of some lessons learned throughout the process, which hopefully will be benefit to those listening today. As you can imagine, we'll be taking more of a high-level overview of the scheme and how MDSuDS provided a solution to the modelling challenges than providing the tutorial and the mechanics of the software itself. This is something XP Solutions provide under separate webinars, and I'm sure many of you have already attended these. So I'm from RG Parkins Partners Ltd, based in our Kendal office. We also have an office in Lancaster and tend to cover Cumbria and most of Lancashire between the two. Primarily we're civil and structural engineers, but flood risk and hydrology side of the office seems to be growing rapidly in recent years as well. On the drainage side, I think it's fair to say Cumbria is perhaps one of the most, if not the most challenging area in England for SuDS design, due to the unusually high rainfall, steep topography and highly varying geology that we face up here. So it's on the back of that, standard SuDS examples often have far fewer site constraints than we typically experience, and as a result, obtaining a viable drainage solution can often be a challenge. As a result of this and our successful design of SuDS schemes, we believe this has allowed us to stand out from the competition and really develop the company and our client base on the back of it. Promise this will be the last sales pitch type slide before we start in anger, but it'd be unfair not to mention our client, Story Homes, at this point. Just briefly, they're founded in 1987 and have a long and successful reputation of building pretty high quality and high spec homes. They're originally based around Carlisle, but they've enjoyed rapid expansion on the back of this success throughout Cumbria, north of England and into Scotland, and currently have offices in Carlisle, Newcastle and Chorley. What we as a consultant feel is particularly noteworthy about Story Homes as a client is their enhanced awareness of the requirements of the approving authorities at planning and their willingness to invest in SuDS schemes like the ones we'll be talking about today as part of their developments. It's obviously a huge positive for us to have such an educated client who encourages these innovative and sustainable solutions and hopefully sees the merit in them. This feeds us into the requirements from Story Homes at the outset of the project and through to the pre-construction phase. We were appointed to provide concept stage engineering input into the scheme and enable access and drainage primarily. This is something of a luxury, and I'm sure many will agree. We often complain of the lack of opportunity to get our voices heard early doors and ensure the engineering challenges are given suitable attention. So no excuses there on this one. Story Homes then obviously requires engineering input to support planning application, which we'll talk more on later, as well as tender and construction information packs. And again, many of you will be very familiar with this process, but there's clearly a huge amount of work involved with taking an awkward farmer's field on the edge of Kendal through to a high-end housing development with desirable homes. Looking at the site itself, obviously in Kendal, for those of you who don't know, the area is highlighted on the screen there for you. You'd probably be pretty hard pressed not to have heard of Kendal if you followed the news and various publications in December 2015 and devastating effects of Storm Desmond. More specifically, it's a 2.1 hectare piece of greenfield land on the western fringes of Kendal. Interestingly, this site's also a gateway to a possible larger development with several of our clients, Stories included, are already looking at. From the blue outline you can see on the screen here, you can see the size of this total land allocation, which is approximately 190 dwellings over 10.8 hectares. The site we're looking at and we'll be talking about today is this red outline here. It was originally intended for 40 houses, but this figure's gradually been reduced to 34. It's relatively low density for the size of the site, but it reflects the large area of undevelopable land. So as you can see from that, it leaves a possible further 150 or so houses over the remaining 8 hectares, which is a pretty considerable site by anybody's standards. And crucially, the site we're focusing on here will provide access to further sites as defined in the local authority land allocation plan, with only an emergency vehicle access route intended from the east. This obviously emphasises the importance of successful progression of this scheme. So just to clarify, this is Brigsdeer Road, and the site we're looking at, and the main access on our road will come in through here and serve the main development. So it's essentially landlocked without this development. All sites have their own challenges and constraints, but this particular one really did seem to go above and beyond in challenging us. Topographical survey on the left you can see there shows instantly how steep the northern corner of the site is. Got gradients in excess of 1 in 3 in places there. And as if this wasn't bad enough, as I've just touched on, the initial draft plan, which is to the right there, put the main access road straight through the middle of this particularly steep area. We did try and steer away from this, but the access point was clearly defined in the land allocation documents, and this possible revisions were coupled with concerns over loss of housing density as a result and complications over land ownership, so we ended up pretty much having to make it work as was. The site's in fact so steep in places that initial site investigation was restricted due to access and genuine concerns over getting the plant in and out safely. We were able to establish that the vast majority of the site's underlain by very shallow topsoil, as little as 300 mil thick, over fissured limestone. It's quite unusual to see a trial pit like the one on the right here that reached bedrock pretty much on the first bucket load with a mini excavator. This was actually my first trial pitting job with RG Parkins, and not exactly what I expected when I arrived at site. Interestingly though, we were able to break out some of this material and achieve successful infiltration tests. Fissured material you can see here on the right in the smaller pictures, broken out with a mini excavator relatively easily, and successful percolation tests into it. Further challenges with the site on the drainage side: essentially no positive surface water drainage or a watercourse in the surrounding area. Foul water drainage is present, but there's currently no highways drainage along Brigsteer Road. The map here shows an apparent watercourse to the north of Brigsteer Road, opposite the site, but the image on the right shows what's actually there. That photo is taken on the far side of Brigsteer Road. This is the site here, just with the road off to the right. As you can see, the watercourse is named Blind Beck, and it's a pretty apt name in that there's no dry weather flow and it's really little more than a waterlogged depression. There's no surface flow in anything other than extreme rainfall in there. And just for good measure, it happens to be landlocked in third-party land with an owner who's actively against the development. The site's in flood zone 1, largely due to its elevated position, but the immediate area is not entirely free from flooding problems. Lack of existing highways drainage likely contributing to the flooding issues such as this on the screen, taken in December 2015, Storm Desmond that we touched on, and resulting essentially from high volume of surface water flow completely overloading the drainage systems. It's a fairly common sight around the UK in extreme weather. This actually shows the junction to the north of the site with an existing development, and something the local authorities were aware of as a problem spot. This particular image was actually uploaded to a site campaigning for the refusal of planning permission. Just to clarify, this is in the junction, as you can see highlighted on the screen, looking back up towards our site, which would be on the left further up. On the subject of planning, the approving authorities for the scheme, South Lakeland District Council for planning itself, who then consult with Cumbria County Council in their capacity as the Highways Authority and the lead local flood authority. In supporting our clients through these planning applications, I'm sure we won't be the only consultants today finding that local authorities are demanding an ever-increasing level of information at this stage, bordering on pretty much detailed design for the highways and drainage aspects. In assessing the proposals, Cumbria County Council currently refer to the non-statutory technical standards for SuDS, published by DEFRA. Those of you who are familiar with this will no doubt agree it's a pretty tough ask to get through all 3 pages of it, but we did, and I'm sure many others have. But joking aside, we understand that Cumbria County Council official SuDS guidance documents may be under development, but are unlikely to be formally issued in the immediate future. We also expect, based on various discussions, that this will be largely based on the Syria SuDS manual. As a result, principles in the SuDS manual are generally to be followed where possible. Cumbria County Council particularly keen to see the surface water disposal hierarchy outlined in the SuDS manual implemented, as are other approving authorities. For those of you who aren't familiar with this, the intention is to prioritise the method of surface water disposal in order of the perceived sustainability. Each of the methods on the screen to be explored fully before moving on to the next. So from complete infiltration right through to discharge to a combined sewer, the idea being that we explore and rule out the options in their various order before moving on to the next. Our surface water drainage strategy, which we submitted at planning, was in accordance with this SuDS hierarchy, proposed to utilise infiltration systems for the majority of the site, percolating into that fissured limestone that we saw earlier in the presentation. These are extracts from our planning drawings showing the layout of the surface water drainage features. Don't have time to run through everything. We'll come on to the important aspects of it. These essentially included use of individual plot soakaways and permeable block paving for the parking areas, private drives and the highway. Where gradients prevented the use of permeable block paving, and we're primarily talking about the main access road into the site here, we propose to use a conveyance swale to discharge water into a deep manhole soakaway at the site entrance. I'm sure many of you are, but for those who aren't familiar with the conveyance approach, essentially formed a localised depression immediately adjacent to the highway and footway, which, together with the crossfall of the road, forces surface water runoff into this purpose-designed drainage channel, conveying it to an infiltration feature at the site entrance for disposal. The section on the left there shows the geometry of this, and the intersection with the highway either side, so you can see the adopted highway and the footway coming in at the sides. You notice there's also a perforated pipe in the base of the swale within a gravel trench, which is intended to enhance infiltration and some storage capacity of this feature. Corresponding long section on the right here shows quite how steep this section of the road from the site entrance down here at Brigadier Road really is. We'd, again, not got time to go hugely into detail with this, but you can all imagine the velocity at which water would flow down a potentially saturated 1 in 10 slope towards a feature at the bottom, which would create an erosion issue and probably losing any potential for infiltration or any storage within the feature, and probably flooding at the site entrance as it failed to discharge to whatever feature was at the bottom. Essentially, it'd be more akin to a conventional piped, unrestricted flow drainage system than a SuDS feature. So to overcome this, we introduced a series of check dams to encourage the water to cascade more gradually down the slope, some surface storage in high rainfall events. Simple detail we've got here on the right shows how we achieve this by placing a physical barrier at 6 metre intervals, which is down this length of swale here. And essentially the idea of this is by preventing water from flowing freely down, we utilise at least a triangle of storage in here and hopefully get some infiltration and reduce the conveyance speed. Coming back to planning and approvals, I think it's fair to say if there's one thing we've learned is important in moving these types of schemes forward, it's consultation with the authorities from an early stage. It's something we're understandably keen to do here given the slightly unconventional approach. From the outset on this one and on other schemes, Cumbria County Council has stated they do not wish to adopt new highways gullies if they can possibly be avoided. This includes discharge to swales and is largely due to their existing maintenance burden and the water quality benefits. And as a result, they're looking to see direct conveyance to the swale. Despite satisfying this with the detail we've just seen, a request from the flood authority to install a petrol interceptor within the site caused confusion. I'm sure those involved wouldn't mind me saying a short-term falling out over the rationale of it. There's also a request from the lead local flood authority to improve the drainage along Brigadier Road, which you can see on the screen there. This was largely due to the flooding issues down at the site entrance that we saw at the beginning of the presentation. Ironically, this is done with a network of 10 new adopted highways gullies, but in fairness, that was pretty much the only option. To cut a long story short, the scheme was actually rejected at planning first time around, citing highways and access issues. Rejection came as a surprise, given positive pre-planning consultation and somewhat contradictory comments regarding the access location, which was the main reasoning for the refusal of planning permission, but had originated from the SLDC land allocation plan. As you can imagine, Story Homes took this decision to appeal, and planning permission was then granted. Something of a relief all round when the decision came, especially given what was at stake with the potential further allocation sites. Post-planning, then undertook further trial pits with the intention of verifying infiltration rates for the infiltration feature at the site entrance to allow our detailed drainage modelling. Unfortunately, this then forced a late design change due to the drastically different conditions in an area of the site where we were facing the biggest challenges with access. Picture on the left you've seen already, the shallow bedrock pretty much at the surface, and then on the right, looking down at the base of an excavation from the top, we have 6.5 metres of very stiff, almost mudstone-esque clay, the beginnings of some groundwater ingress that you can possibly make out in the base there, which is obviously not exactly ideal for an infiltration feature. As a result, we had a revised drainage strategy for the main access road. Just to clarify at this point, the remainder of the site using permeable block paving and individual soakways remained as per the planning drawings. It's just the steep main access road that we're looking at here and requiring a different approach following the trial pitting. So to do this, we switched out the infiltration feature for a detention basin with a flow control device. Managed to agree with Cumbria County Council. We discharged the highways drainage at a controlled rate of 3 litres a second. This limit was imposed by Cumbria County Council on the basis of greenfield calculations. And we did argue for a higher rate, but 3 litres was what we agreed. This is also on the proviso that positive drainage of Brigsteer Road be added at the developer's expense, and improvements to the area where you saw the flooding early on be made. On the left, a plan with the new drainage, and the image to the right shows the existing feature. Essentially, we're introducing a small pipe under the footway here, which discharges down through essentially an informal swale further down out of the shot here and eventually discharges to land. So, in a nutshell, we're increasing the conveyance capacity under the footway here by adding a larger pipe, and we're also introducing these network of gullies which will add some additional flow but pretty negligible limit. So hopefully a win-win situation in alleviating existing problems and draining our site in a sustainable way. Adoptions are always key on these types of schemes. Swale and detention basin on this one, despite being heavily influenced by Cumbria County Council, were actually declined for adoption due to concerns over their maintenance. And at present, we go as far as to work on the premise that no soft landscaped areas will become adopted highway, purely and simply because the Highways Authority are apparently already overstretched with their existing maintenance responsibilities. Consequently, swale and basin remain private, which introduces a third-party management company, and ultimately the residents will have to pay a service charge to cover this maintenance. Highways have agreed on this one to adopt permeable block paving on the minor access road, which is everything from this junction into the development. This is all to become adopted highway. This hasn't always been the case in the past, as I'm sure others will have found, but it's encouraging to see this being supported on this scheme. Got section 1 and 4 in place for foul water drainage, but surface water drainage is not discharging to United Utilities sewer, so there's no further requirements for United Utilities there. Highways drainage along Brigsteer Road should be adopted by Cumbria County Council from the flow control chamber, which will be just downstream of the detention basin, and including all this new highways drainage. Planning conditions introduced at the time of the appeal decision detailed that drainage modelling must be undertaken to essentially demonstrate what we were proposing was suitable, and fair enough. As you can imagine, there's some pretty unusual challenges associated with designing and modelling a swale on such a steep site. When we're looking at swales, you look at typical examples, tend to think of something like this on the left, rather than attempting to bring a swale pretty much perpendicular down this sort of slope. This image was taken from the footway on Brigsteer Road, looking back up into the site, and is approximately at the site entrance. On this and previous schemes, when we're looking at a swale on such a steep slope as this, multiple swale sections divided by check dams, as we touched on earlier, and direct inflow from highway and footway. This introduces problems with modelling, and the swale was also specified as a partial infiltration system with a perforated pipe in the base, again, difficult to model. Previously, we'd used the network module of MicroDrainage for this, but ultimately we felt we weren't using the right tools for the job in attempting to manipulate it to give us the data that we needed. I'm not suggesting anybody adopts this approach on the back of this, but to model the swale in network required each section of the swale, so every 6 meters, to be modelled as a separate conduit with an associated flow control and storage structure manually inputted. The process is obviously time consuming, and any further layout alterations required significant work, so it's obviously not a cost effective or time effective approach. So why do we pick MDSuDS as a tool to overcome these challenges? In short, the capability to model SuDS truly in 3D and the increased sophistication in analysis that we were looking for. The software was actually launched a few months before we began attempting to model this, and we were fortunate enough to be aware of that at the time. Essentially, the ability to properly connect SuDS features in a 3D site model was and very much still is something that we were drawn to. Again, I won't attempt to list all the features of the package here, as XP are best doing this, but it certainly offered what we were looking for, and it came with increased confidence in the analysis results as a consequence. We could also see the potential for efficiency improvements using what's essentially a fit-for-purpose package. From this, you can imagine we obviously took the plunge, invested in the package, and I think it's fair to say, as with any software, it's an initial learning curve. But fortunately, we did have a large amount of support from XP Solutions at this stage in order to get this software up and running and hit the ground running with it. Crucially for us, this was followed up by on-site training with Max and a detailed discussion of the direct project application of the software, and we looked at this scheme in particular. Perhaps important also to note at this stage that we currently use another common earthworks modelling package, which is outside of the XP Solutions suite and will obviously remain strictly anonymous. So we were keen to review the crossovers between the two in terms of the 3D site modelling and looking to reduce the amount of work that had to be repeated. And again, after some initial difficulty with this, it became apparent that the two are more or less directly compatible with one another, which is hugely important for us. On the screen, you can see a digital surface model, which is generated in MDSuDS, and the vast majority of this was directly imported from our other modelling package, having previously been generated earlier in the project. But briefly, you can see the outlines of the highway and the key drainage features of the swale down here, and this obviously saved a huge amount of time with it bringing this pretty much straight in. Due to the stage of the scheme at which we adopted MDSuDS, we primarily employed it as a detailed design tool at this particular scheme. We use MDSuDS primarily in modelling the swales, and the geometry of the swales has been developed beforehand using network, as we said, in our 3D earthworks software. So it was essentially verification of this design that we were principally concerned with in MDSuDS on this job. Just to recap again, highways runoff enters the swale via a series of inflows, the carriageway and the footway. The contributing areas were easily assigned in MDSuDS based on the areas draining to each section. So you can see the sections of swale being added here with the various inflows and flow controls, and then the corresponding area draining to each. I think one of the major advances for us in this process is being able to apply this over the top of the CAD plan, which you can see in the background here, and it really is helpful to be able to keep track of what you're doing rather than just having references and coordinates as in other packages. Hydraulically, the swales modelled as conveyance swales to simulate a worst case scenario where we're achieving zero infiltration prior to outfall to the detention basin at the entrance. This was due to the steep gradients of the site and the real possibility of underlying ground in the trench there becoming temporarily saturated. We decided to model under these conditions to ensure resilience within the system and make double sure we're providing adequate storage in the basin. Conveyance from the point inflows along the swales, modelled as a series of weir control structures, simulate the inclusion of the check dams that we touched on. This obviously prevents the pass-forward of flows from one model swale section to the next before we reach a specified level. And the zero infiltration rate in the base, under this design scenario, we would not be expecting water to enter that infiltration trench and hence the below ground perforated pipe. So no allowance was made in this run of the modelling for this, but MDSuDS is very much capable of doing this, which would obviously be something we'd look at in a less extreme design situation. But we felt in this case it was a true reflection of what we were likely to achieve. Orifice on the right of the screen there represents the pipe from the final swale section to the detention basin. Again, due to the stage of the scheme when we began using MDSuDS, the work we'd already completed on soakways and permeable paving or the MicroDrainage modules wasn't directly repeated here. You can bring everything into the model, but due to the time pressures, we just modelled the swales. This is obviously something we'd look to explore more in future, but the crucial aspect was the linking of the different swale sections in 3D for us here. In terms of the results at the end of this process, deluge function, routing a 50 mm rainfall event onto the site, identified an issue with longitudinal gradients of the main road and resulted in a small change to the drainage design. We're confident this would have been spotted at some stage, but demonstrates the power of the function in performing what's essentially sanity checks as well as complex modelling. Just broadly, the graphics on the screen give us a visual indication of this and show the various depths of water accumulating in areas of the site. This also identifies an issue at the site entrance with water not actually reaching the swale and some separate ponding elsewhere in the development. All of this was then dealt with in the next iteration of detailed design before rerunning the analysis. Essentially, the good news for us on this was that the swale as originally designed was deemed to be adequate for the design storm events, and due to the stage of the scheme, the geometry was pretty much fixed already. But there would have been some small amount of room to modify this had space been an absolute premium, or had we been looking at it at an earlier stage. And we'll obviously look at this in future schemes when we've got more freedom with the layout. Similarly, basin and outfall analysed with some small adjustments to the storage volumes and levels. From this, comprehensive outputs, similar to those you'll be familiar with in the MicroDrainage suites, then submitted to the local authority, submitted a detailed drainage report to Cumbria County Council, which resulted in the discharge of the planning conditions. We can only assume they were reassured by the level of modelling and information that was provided. Interestingly, no further mention of the petrol interceptor. As you can see on the screen here, numerical modelling of this aspect can and was undertaken in MDSuDS, which demonstrated that sufficient treatment of the highways runoff will be achieved without petrol interceptor. So where is the scheme today? Highways and drainage planning conditions have been discharged. There's some ongoing but separate issues with section 278, the highways, challenges at the site entrance, and a new public footpath that's been created there. These are yet to be resolved fully, but a groundwork is due to be appointed shortly, anticipating start on site around April this year. It's still acknowledged that viability is a concern, largely due to the access and the 278 works, but it's possible that this is being looked at as partially as an investment to enable the future allocation that we looked at the start of the presentation. To summarise then, we only used MDSuDS, a detailed design, as an analysis tool on this scheme, which was perfectly satisfactory at the time and a huge improvement on what we already had. But we can also see a significant potential in the use of the software at feasibility stage to establish a workable drainage strategy. The benefits in terms of efficiency and accuracy could obviously be pretty substantial from this. Taking a holistic approach to drainage assessment, modelling everything in one place, give us a greater confidence in the design as a whole. Previous schemes have been designed piecemeal with individual elements invested in source control and network, etc. But bringing everything together is obviously pretty attractive. Ultimately, in an industry where designs and particularly drainage proposals are under ever increasing scrutiny, I think numerical verification of these principles that we're putting forward can be invaluable in arguing for their merit. As we've seen, 3D wide site technology identified problems we possibly didn't know existed at that stage, and this could obviously have huge impact on site in reducing redesign and later costly changes. Having gone through the 3D modelling process and discussed the difficulties and the limitations with XP on this, obviously be better informed to address these from an earlier stage. Additional time spent creating the digital ground models or whatever you're using in your various earthworks packages with the knowledge of the requirements of MDSuDS could be largely recuperated by streamlining the MDSuDS process. And finally, the support from XP solutions that we received on this really helped us hit the ground running and utilise the software in a short space of time, which was absolutely what we were looking for. Thank you very much. I hope that's been of benefit to people, and I'll hopefully hand you back over to Peter.
Brilliant. Thank you. There are some questions. So thanks for the questions, folks. I've answered the majority, but there's one that I just would like to float by you, Peter. There's a question from Greg. Were there any issues associated with either sinkholes being present in that fissured limestone or sinkholes developing? Was there any kind of concerns raised by the approving authorities about sinkholes developing, I suppose, whilst infiltrating into those structures? I don't know if you could sort of elaborate on that a little bit, or whether we could sort of answer that afterwards.
Just to briefly, we had a geotechnical expert involved in the scheme and pretty thorough ground investigation, and there was nothing returned of that kind of note. Obviously, it's something that we've considered with their advice, but short answer, no, there's no issues on that or any indication that we need to put any particular measures in place to prevent.
Super, thanks for that, Peter. Another one's popped up from Jason. Thanks, Jason. How did you achieve the 3 litre per second discharge rate from the basin outfall? I'm assuming he's talking about limiting the discharge rate. Maybe I glazed over that, but there was a hydrobrake chamber on the downstream end of the flow control there with a small orifice to limit that. Perfect. Thanks, Peter. And it was such an insightful and fascinating case study for me. I really appreciated that. And we'd like to thank you, and we'd like to thank RG Parkins and Partners, as well as the client, Story Homes, for sharing this really excellent case study. I suppose the only good news is you're in flood zone 1. I couldn't believe the barriers that hurdles you had to vault over and through on this project. But well done, it's a credit to you all. And you're in flood zone 1, and then you had localized flooding, pluvial flooding anyway, so it wasn't a lot of good news really, was it? But in conclusion, just to put up my final concluding slides and to let people know how to obtain their CPD certificates. Sorry, I just need to share my screen again here. Just in conclusion, the key points that I sort of drew from this, and to sum up really, were how SuDS can really provide those innovative solutions even on such difficult sites. And this is all providing early consultation with all of those stakeholders. I think that's one of the emphases that I hear, and it resonates across the country when I travel, is early engagement. So again, credit to everyone involved on engaging at the early stage with this. Certainly using the latest technology backed up with that appropriate support and training, that does help improve the delivery. It was really pleasing to see that the MDSuDS did help to provide those sanity checks, as well as gaining the all-important approval at the end of the day after that initial refusal. And the teamwork involved. I mean, the key thing for me, again, is it really emanates right the way down through from the client and below. And it's absolutely key. So the final outcome, when you have the right attitude from the client, the can-do attitude, certainly looking towards the future, which is a credit to them, as well as like quality engineers like RG Parkins Partners and Peter and Toby and the team there working diligently on such issues. The final outcome is growth, both in terms of competence, in terms of confidence, not just on this, but for future projects. And we really do value your sharing these experiences with us. It was excellent. Thank you very much. In terms of the upcoming events and talking about improving ourselves for the future, we really are busy with the training. Max and I and Mike are traveling the country. We're doing a lot of off-site training, but we do run regular events here in the Newbury Training Centre. The next ones coming up will be on the 30th of the month. We have a day's training on Course H, MicroDrainage training on Course H. This is the auditing and checking kind of course. So we have a lot of local authorities, water companies, and sort of senior engineers who want to just check what's happening before you submit your final technical submissions. We're then running a series on the 7th to 9th of February covering the basics, Course A and Course B. These typically fill up very quickly, and then the more specialized courses we run kind of every other month. Course C is the graphical interface and slightly more advanced modeling course. So we're working with the DrawNet functionality and also adding in swales, as Peter's shown us here. We're adding in swales into the network model, copying and pasting whole branch lines, and how to kind of work more efficiently, really, and more quickly. If you go beyond the design and you're looking at flood risk assessments, or you have existing flooding issues, this lends itself to the modeling software, the XP Swim, XP Storm modeling software, and we have 3 days of training of that coming up in the middle of the month. So happy Valentine's Day for those that arrive on the 14th. I don't think we've got the chocolates and flowers ready yet, but we have 3 excellent days of training with the team here. With regard to the next webinar, this is happening on the 6th of February, and note to ourselves that it's on a Monday. The diary is absolutely chock-a-block, so we've had to divert away from the regular Wednesday events for this particular one, and it will be run on Monday at midday, 6th of February. And the subject of the webinar will be assessing flooding consequences of a new drainage design. So we're going beyond the design and then assessing the flooding consequences of a new drainage design. And then on the 1st of March, really interesting, the ground modeling, it wasn't done in XP Site 3D, but this is our road design and ground modeling package. It is very quick and easy and intuitive to use. We have just developed a 1-day training course. No one's really asked for it, but one or two have said we've used it for a while. It'd be nice to have a day to just really pick our brains and see if there's any shortcuts and what have you. So we are running a 1-day XP Site 3D training event for those that have got the XP Site 3D software or are looking to purchase and invest in XP Site 3D. So you'd be welcome to come along to that. There will be some workshops happening around the country. We'll send out an e-cast to bring you up to date with that. These are free morning workshops. And when we travel up to the north, I'm thinking Leeds and places like that, the plan is that we run a couple of days of training whilst we're up there as well. So we'll probably lead with a day or two of training and then run a workshop, or run a workshop and then a day or two of training. Again, we'll keep you posted through an up-to-date email from marketing. Thanks for the questions. There was a question from Roy about the frequently asked question sheets on previous events. So yeah, we've produced FAQs in the PDF kind of a format, Roy. And what I'll do is I'll ask marketing to send out the link or the links to those PDFs, or if you haven't got them for particular events, feel free to email in UK Education. And once more, I'd just like to thank Peter in particular, RG Parkins and Partners, and Story Homes for sharing this excellent case study and experience with us, and look forward to engaging with you all at the future event. Take care, and bye from Max, and
thank you.
Bye from me. Thank you one and all. Bye for now.